Compressible flow tutorial number 9. Consider a one-dimensional isentropic flow of a gas through a duct. At a certain section of this duct, the gas velocity is 350 meters per second. The temperature is 50 degrees Celsius and the pressure is 130 kilopascal. Find the Mach number, the stagnation temperature, and the stagnation pressure at this point in the flow. If the temperature at some other point in the flow is 20 degrees Celsius, find the Mach number and pressure at this point. Take the specific heat ratio of K equal 1.4 and the gas constant R equal to 287 joule over kilogram Kelvin. In this situation, we need to understand that we have a duct. Then, one type of gas flow inside this duct. The gas velocity is 350 meters per second and temperature is 50 degrees Celsius and the pressure is 130 kilopascal. We need to find what is the Mach number for this condition. After that, if we stop the gas flow immediately, it becomes stagnation. Then we need to calculate what is the stagnation temperature and the stagnation pressure for that situation, means for the stagnation condition. You cannot say that because the question asks you to calculate the stagnation temperature and the stagnation pressure here, the Mach number here will automatically become 0. No, that is not the meaning of this question. Please be careful. Then, at another point in the duct, the temperature reduced to 20 degrees Celsius and we need to calculate what is the Mach number for that flow and what is the pressure at that point. This is the equation of Mach number. Mach number equal velocity over speed of sound. We could write as V over third kRt. We substitute with all the parameter that we could get from the question. We could get Mach number is 0.9715. Then, if this flow is immediately stopped, we could say that the velocity is 0, so the Mach number will become 0 too. Because we have two temperatures, we need to calculate the stagnation temperature, so we use the equation for this one, the isotropic flow equation for temperature ratio. From this equation, we could substitute all the value. We assume that T2 is equal to stagnation temperature. T1 can be substituted with 323 as stated in the question. Mach number 2 is equal to 0 because it is a stagnation condition, and Mach number 2 is equal to 0.9715 as we calculated previously here. We calculate this equation. Finally, we could say that stagnation temperature is equal to 384 Kelvin. So to calculate the stagnation pressure, we have isentropic flow pressure ratio equation as this one. So we could assume that P2 here is stagnation pressure, P1 is given in the question, Mach number 2 is equal to stagnation condition, which is equal to 0, and Mach number 1 can be found in previous calculation. We know that the gas is air, so the value of K is equal 1.4. So we have K over K minus 1, it will become 1.4 over 0.4. We could solve this problem, this calculation, and we get stagnation pressure is equal to 238 kilopascal. And then for the next question, in other point in that duct, the temperature reduced into 20 degrees Celsius, which is equal to 293 Kelvin. We need to calculate the value of Mach number on that point. Normally, if we have two readings of temperature, so we could use this equation by substitute the value of T2 is the second point temperature, 293. T1 is the previous temperature, which is 323. And then we could put Mach number M2 here is Mach number that we want to calculate, and Mach number 1 here is Mach number that we calculated previously. We could solve this equation, and then we could get Mach number 2 is 1.246. And we do the same calculation by using pressure ratio equation of this one. You could substitute all the values, and you could get P2 is equal 92.4 kilopascal.